Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. My name is Ravinder. I am an assistant professor with ETC department. And in this video lecture series, we are discussing the subject Object Technologies and Programming in Java, that is OT&P. And for past two lectures, we are discussing the chapter or we are discussing the important topic called multi-threading, and this lecture would be the last leg of this topic, multi-threading. So we're going to start our third lecture for multi-threading. So let's move ahead to the notes. Now, in the yesterday's lecture, I have shown you how you can manage to make one how you can manage to make one of the let's say thread to wait while other thread will terminate its execution. Now in the last lecture I have shown you an example in which the main thread actually sleeps for a particular amount of time until and unless the other thread, the secondary thread, which is the custom thread that we have made by ourselves by creating a class, stops executing, because as we know that only the main thread must be the first thread and be the last thread to be executing. Okay, now we have used the wait method extensively in that particular example, but well, let me say that there are two methods with which you can remove that sleep method to make the main thread aware of which secondary threads are terminated or not. What I am trying to say is, instead of calculating the time for the sleep inside the main thread, okay, let's say I have to wait for 5,000 milliseconds because the secondary thread will be alive for let's say 4,000 milliseconds. Instead of doing calculating, all we can do is there we can derive a method by which tells us when the secondary thread is terminated, or is secondary thread is still alive or not, or if there is a method which waits until the secondary thread is terminated, then I think the need for sleep method will be obsolete. So this is what we are going to study today. Our first method is alive method, and our next method is the join method. Okay, I will read it out the notes. In all the preceding examples, we have called the sleep method in the main in order to ensure that the main thread finishes last. Okay, we have just discussed that. However, the thread class defines a method to determine whether a thread has finished or not. And that method is isAlive. Now, isAlive method, if you call isAlive method on an object of let's say some other thread, then this method will return you a boolean let's say data that is true or false, and the true and false will define whether the thread is alive or not. For example, in the last example that we have seen, if the secondary thread, or I will not call it secondary, if the customized thread that we have made for ourselves, we can and we have instantiated an object of that in the main class, and if that on that object we have called the method called isAlive, then isAlive will actually tell me whether that particular thread is still executing or not. And if that particular thread is executing, I will be returned with the value true. And if that particular thread is not executed or has already been terminated, then that method isAlive will return us with the value called false. So your main thread can find out whether the second thread, which is executing parallelly to the main thread, is still executing or not, or we can say it has been terminated or not. We'll see the example of this particular method in a while. So let's move on. Now the second main concern is that using sleep method is not an issue. The issue is that we have to calculate the exact amount of time which must exceeds all the other threads for the main thread to wait. That is, if we want our main thread to be terminating in the end of the application, that is after all the other threads have been terminated, then we have to precisely calculate the time which must exceed the execution time of all the other threads, and which is a cumbersome task and in some cases will not be possible at all. So in that case we have a let's say we have a method called join method, and this join method, when called upon an object of some other thread class, will actually wait until that particular thread ends. Okay, and it will not allow the compiler or the Java runtime environment to move to the next command or to relinquish the control to the next line of code unless and until that particular thread has been terminated completely. Okay, so join basically is called sleep until the other thread has been terminated. So in that case, the runtime environment will eventually wait until all the thread on which the join method has been called is terminated or not. Okay, so you don't have to calculate the sleep time for that. So let's move ahead. I will show you an example. What I'm trying to say here, it will make more sense when you will see a running example or a live example. So here we have created a thread class, the custom thread class called new thread. As you can see, it implements the interface runnable. So all we have to do is just initialize a string called name. You can do that or not. It's entirely up to you. As I've shown in the last example, this is not necessary for you to define this here. And a variable of type thread, which we are going to develop it as an object of class thread in a short while. Now I have called upon the constructor of class new thread, and which actually accepts the argument, the name of the thread. We have discussed this already in the last class. You can refer to the last class if you don't remember that. Now, first we will create the object of thread class new thread. This is actually, we have discussed in the last class again, the object of the new thread class, which we have passed to the object of the thread class. Now the T object, which is of class thread, encapsulates the object of the new thread class and the name. Now this new thread T has actually, or you can say the new thread which has been defined by this class new thread, has a name which you have inputted when you created the object in the main class. I'll show you in the few minutes from now. And then we have called the start method. Okay, so as soon as the constructor has been called while creating the object, the new thread will start executing. We have all discussed that already. Now I have called the only method which has been defined in the runnable interface called run, and inside that first we'll start the try catch block. As you know that the methods of the thread class tend to throw out some interrupted exceptions from time to time, so you must be aware of that. Now inside this we'll initiate a for loop. We have done this already, I think. It can make sense to you that the sleep method has been called, which will wait for 1000 milliseconds, and I have initiated it for run. I'm trying to run this particular loop for 3 times. So in total, this particular thread, which is defined by new thread class, will in total sleep for 3000 milliseconds. Okay, so now we'll get out of the new thread class and we'll be inside the main class, not the main class, join demo class, which actually have the main method. And inside the main method, I will instantiate 3 objects of new thread class called T1, T2, and T3. I will name them as first, second, and third. And first, I will try to print 3 system.out.println statement to see if all the 3 threads are alive or not. As I have already told you, when you try to create the object of the class new thread, as inside the constructor we have mentioned the object the method start. So this, when the object has been created of the new thread class and its constructor has been called, the thread will start automatically. The first thread has been started, second thread has been started, and third thread has been started. So when you try to access the method, t1 is alive. Okay, I think this t must not be there, so you can omit that t. If you try to omit this, let's say, sorry. So when you try to do this, uh, is alive method, this is alive method will return you a true. It means yes that yes, the thread T1, or its name as first is actually alive and executing, and second one will also return to you true. It means the second thread is alive and it will return you as true. So you have called the methods is alive for the objects t1, t2, and t3. I have also let's say t2 dot t, because is alive method actually belongs to the method call, actually belongs to the object t, which is in return an object of the thread class. So I've object has called on object, and then it has called on a particular let's say what can I say, method. Okay, so I am taking help of another object, which in turn is helping me with its method called isAlive. So there's nothing complicated here. All you have to do just is T1 will contact to the object T, whereas T has been already defined inside the new thread class, and that T actually is of class thread, and thread has an method called isAlive, which returns true or false depending upon that particular thread is still executing or not. That is it. Now we'll start a try block, and inside this try block we'll again call a method called join. Now for thread 1 or first we called join, for second we'll call join, and for third we'll call join. And the execution will not move on until the first one has been terminated, the second one has been terminated, and third one has been terminated. Okay, so the join method actually make runtime environment waits until the thread on which it has been called terminated completely. So the runtime environment or the application programmer don't have to calculate the sleep time itself. Okay, uh, runtime environment will wait until the stipulated time of the running thread has been completely gone or run out, and after that the termination of the first thread, we will go to the next line, and again a join function method will be called. Again the system will wait until that second thread has been terminated, and then again we'll move on to next. Again the join will be called, but this time for the third thread. As you can see, it has been called by the object t third, and again the system will wait until the thread has been completely terminated, and after that we'll move out of the try catch block. And when we try to run this, as you can see, first thread is alive true, second thread is alive true, third thread is alive true. Now these trues are actually brought to you by isAlive method. So it means that all the three threads are alive and up and running. And after that, inside the try block, all the threads will share the CPU space, first, second, third, first, second, third. The order can be different for depends upon the CPU capacity. And after that, exiting first, exiting third, exiting second means that after the termination only we have moved on out of the try block. Okay, and if after all this you called upon isAlive method again for all the three threads called first, second, third, now at this time you will got the message false, 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 and in the end the main thread will terminate. So as you can see, join method and isAlive method are both of them combinedly will tell you or will help you to control your execution of main method, the main thread, or the termination of your main thread, and will ensure that your main thread must be terminated only after all the other threads have been terminated completely. Okay, so let's move ahead. We have a lot to cover up in this lecture. Next is thread priorities. Suppose you want, see, threads are just a block of codes which will perform a particular task, or you can say threads are particularly a task only. So let's say you have three or four, you have two threads or three threads running at the same time. One would be the main thread, obviously. Second, two other threads will be performing their own task, which we have defined in their run methods. Now you want, suppose you want that your task 1 must be prioritized over the task 2, or your thread 1 must be prioritized over your thread 2. It means after the main method or the main thread, the two other threads which are running simultaneously, that is thread 1 and thread 2, you want your thread 1 to be prioritized by the CPU and the runtime environment over the thread 2. It means more CPU time should be allocated to the thread 1 and less thread CPU time must be allocated to the thread 2. In that way, the task that is being stipulated by you to the thread 1 must be prioritized, and the other task that is being stipulated by you to the thread 2 must be it will go on. It will have its own CPU time, but that would be less than the CPU time that thread 1 will get. So what I'm trying to say is you have two tasks that are running simultaneously, but you want your task 1 to be prioritized with respect to your task 2. So that can be done in the Java using the thread priorities. All you have to do is set the priority of a particular thread and see uh, and wait if after setting the thread priority, if you have set that below the normal priority, so then stipulated CPU time for that particular thread will be reduced. And if this priority of a particular thread has been increased by up by from your normal priority, then the CPU time will be increased for that particular thread. So what I am trying to say is we have three parameters. First is minimum priority, second one is maximum priority, and the last one is normal priority or norm priority. Now basically min priority has a value 1, max priority has a value 10 normally, that is by default, and norm priority has a value of 5. So actually whenever you start your threads in the main thread, all of the threads have same priority, that is equal to 5. That is by default. If you want your thread to be prioritized over all the other threads, then you have to set the max priority of that particular thread. Okay, if you set the max priority of a particular thread above 5, that is between 5 to 10, it means the Java runtime environment will let's say infer from it, will know that okay, you want this task which is this particular thread to be prioritized, so it will allocate more CPU time to that particular thread instead of all the other threads. Okay, so all you have to do is set the priorities, the min priority, max priority above the 5 or below the 5. If max priority in the starting, at the beginning, min priority and max priority both will be set equal to 5 by default, that is equal to normal priority. If you increase the max priority, the particular thread will get more CPU time. If you decrease the min priority, the particular CPU time for that particular thread will be decreased as respect to other threads. So we see that in the example. Okay, we have created a class called demo which implements runnable. It means that we are trying to create a thread out of this demo class, and inside that I have initialized a variable I of type integer equal to 0, a thread variable t, uh, a variable of type boolean equal to true, and then I have called the constructor and created the new thread, uh, that is created the object of class thread and encapsulated that which and have passed the object of class demo to this particular thread, which you can see by using the word keyword this. And then I have set the priority of this particular thread equal to p. Now I have taken the p as an argument when you call the object, or when you try to call the constructor of this particular class demo. So now whatever be the value of p will set the priority of this new thread. Okay, now I've called the run. I've called the method called run, and while running, which is been set by me equal to true in the starting, I will increase the counter. And I have also defined a method called stop. All these methods called run, stop, and start are actually been created by, no, stop and start are created by me actually. Okay, so inside the stop I will put running equal to false, and inside the start method I have just called the method which has been defined inside the thread t, that is t dot start, which for the last few examples we are doing this inside the constructor only, if you can recall that. So that is it. That is about the demo class. We haven't done anything new in here. All we have done is called the method set priority and passed to it integer value called p, which will decide the priority of thread. So inside the main thread, what we'll do is we'll try to create two objects of class demo. First is hi, HIGH, or for short hi, and I have passed an integer value, that is thread dot norm priority plus 2. Now as you can recall, the normal priority of any thread by default is 5. So this is basically 5 plus 2 equal to 7. And then an other object called low priority, or LO, I have passed on the argument, the integer value, which is thread dot norm priority, which is equal to 5 minus 2, that is equal to 3. So I've passed 7 here, I have passed 3 here. So as you can see, the thread which has been signified by this name high has a priority of 7, that is above the normal 5, and other one named as low, other thread which has been not named but signified this particular object low, has a priority which is less than normal, that is less than 5 and equal to 3. So I've started both of them. Now inside the try block, the main thread will sleep for some time. After that, we will stop the both of the threads. Again, we'll see if they have terminated completely or not by using the join methods, as we have done in the last example. And after that, all we have done is stated up the count, that how many times the low priority thread is counted and how many times the high priority have counted. So in this way you can see that the priority, if you try to run this particular example, you will see that the high object, the thread which has been initiated by the high object, will get more CPU time, or the last count of this particular object will be more in uh, in contrast to the thread which has been defined by the LO object, because the more CPU time will be assigned to the high priority thread with respect to low priority thread, and as more time will be assigned to the one thread, it will count more with respect to other thread. So that is, so we have a last topic left with us called synchronization. Now what is synchronization? Synchronization means that suppose if two threads are trying to access a same resource, and you know that trying to access some resources will not cannot be done at the same time. It means that if you're trying to open a file and if some other thread is trying to open the same file, and if the access to that particular file has been allowed to only one of the threads, then it will lead to a clash of the control of that particular file within the threads. It means if there is a resource which can be accessed one at a time, and if there are more than one thread competing to access that particular resource at the same time, so the actions of all those threads must be synchronized. Otherwise, there will be clash of control between those threads, or they will start competing with each other, and your application may crash then and there. So I will read out the note so it will become more clear. It is possible that two or more threads are required to access a common resource. Therefore, there has to be some way to ensure that resource would be used only one thread at a time. The process by which this is achieved is called synchronization, as we have discussed a few seconds ago. A monitor is an object that is used as mutually exclusive lock or mutex. Only one thread can own a monitor at a given time. When a thread acquires a lock, see, monitor is a concept which has been associated with an object. Okay. Now, monitor is, you can see, can in the layman terms can call it as the control. So the control of a particular resource, which in Java we call it a monitor, can be accessed by only one thread at a time. And after the one particular thread, let's say, stops the mining of the resource, it will relinquish the control, that is, it will relinquish the monitor, and then only after that, other thread can come in, will take the control of the monitor, will start mining the resource, and after that it has completed the mining of the resource, it will again relinquish the monitor, that is the control for some other thread to continue. So all you can see here is, all you can understand here is, control monitor is like a control. So, and that control can be given to a particular thread at a time or one thread at a time. So you must understand that the passing on of control or monitor from one thread to another thread must be synchronized, otherwise there will be clashes. Now we can do this by using the keyword synchronized. So synchronized is the keyword. If you associate it with a particular method, then only one of the threads would be able to access the monitor of the particular method, and while the one of the thread is taking control of the monitor of a method which has been termed as synchronized, all the other threads will be waiting or will be termed as suspended until the control of that particular method or monitor of that particular method has been relinquished by the thread that is executing it at the first place. So I'm trying to say that if we have three threads called 1, 2, 3, and at the beginning there's a method called, let's say, a display, and that method has been we have defined this method as synchronized method by using the keyword synchronized before the name of the method. We'll see that in a moment. And if all the three threads will compete to access the same method display at the same time, and if the thread 1, which has been named 1, will take the monitor of the method display, then at that time the thread 2 and 3 will remain suspended until the thread 1 will relinquish the monitor for some other threads or for thread 2 and 3. Okay, so basically while thread 1 is doing its stuff for inside for or using the main method, or sorry, by using the display method, the thread 2nd and 3rd will remain suspended if they want the control of the display method at the same time. So it's like you're waiting in a line, and while the shopkeeper is attending you, all the other shopkeepers have to stand in a line and do nothing. It's like that. Okay, a shopkeeper and the shop can be termed as the method which has been synchronized, and you are the thread. So while you are using the shop, that is using the method, so you have the control of the monitor. That is, you have the monitor of that particular shop or that particular method. And while other two threads, which let's say the people which are standing behind you are other threads, they will wait for their turn. And that is it. This is all what synchronization means. So it's like making a line for at the ticketing counter. You have to wait for your turn, or the threads have to wait for their turn, because only one of the customer can be handled at a time if that particular method has been termed as synchronized. Okay, so let's see an example. Okay, now I have defined a class called first, and I think, okay, I have not defined is as implementing the runnable, so I'm not trying to start a new thread here. It will be the main thread only. So synchronized, I've defined inside the class first a new method called display, which has been termed by me as synchronized. As you can see, to synchronize a particular method, all you have to do is put synchronized keyword before all the other designations of the method, or before the signature of the method. So its signature now becomes synchronized void display. Means this particular method is synchronized, so its monitor will be handed over to one particular thread at a time, and all the other threads trying to gain access to the monitor of the uh, display method, we have to wait. Okay, and it is returning nothing. It's just trying to print out a string s, and the thread on which this particular display method is playing will sleep for 1000 seconds. So we'll get out, and inside the thread class, now we have trying to implement a class called try to construct a class called second, which implements runnable interface. It means we are trying to start a new thread here. So we have initiated a new thread here by using t, and we started it inside the constructor, and inside the run all we have done is we have called on the display method of the class which we have defined earlier, that is the first class. Now how will we able to do that? Because I have created the object of class first here. Okay, and now we'll go inside the main class, and inside the main class first I have created the object of first class, and then three objects of class second. Now let me remind you that first class don't hold any other thread, new thread, but second class is a new thread, or being constructed by me as new thread because it implements the runnable interface. So when all the three objects are instantiated automatically, as you can see the constructor of the second class, this class here, and it will accept argument of an object of class first, which is this class. So I have passed on here an object of class first to all the three and the names. So as soon as the constructor has been called, the thread has started, and as the object of first, the ob1 has been constructed first or instantiated first, it will be started first. The run method will start first for this particular thread, and it will call the display method. Okay, now as you can see inside the display method, the thread sleeps for 1000 milliseconds. Now while the thread sleeps for 1000 milliseconds, and let me tell you, this particular thread is actually the thread which has been named as first. The thread second and third can compete for the display method. Okay, because first thread has now been sleeping for 1000 milliseconds. But if we allow to do, if we don't put the synchronized keyword ahead of this particular method display, then all the other threads, that is thread second and thread number thread named as third will also access the display, and you won't be able to see which one of the thread is actually using the display. So what I have done is I have put the keyword synchronized in front of the display method, and as you can see, while the first thread has been sleeping in the display method, the second and third threads are actually waiting outside or remain suspended until the first thread comes out of the display method. So you can say the first, second, and third threads are synchronized by in using the method display. Okay, so I will going to end this lecture now.